Hello everyone, welcome to our new video of our playlist. Today's topic for the video would be searching techniques. So there are different types of searching techniques and we would start with the very basic one, which is the linear search. So the contents of this video would be what is linear search algorithm and different types of cases in linear search. So what is linear search? Linear search is a searching algorithm. It is also known as sequential search. In this technique, we keep on comparing each element with the element to search until it's found or the list ends. So as you can see in the GIF below here, you could see we are given an array, and in that array we are given different types of elements. So we start from the left side, and then accordingly we go to the right, and it compares each and every element with the desired element until we find the desired element. Once we find the desired element, as you can see here, the desired element is 33. So it keeps on comparing, it iterates through the array and see each and every element whether it is equal to the desired element. So here you can see this is how the linear search algorithm works. So you would see the algorithm. So this is a very simple approach. You have to start from the leftmost element of the array and one by one compare x with each element of the array. So x is the element which we desire, which we want to find. So if x matches with an element, return the index where the element is. And if x doesn't match with any of the elements, return -1. Now, as you can see here, we have already included a library which we would be needing, which is the IOStream library. And we have also mentioned using namespace is equal to std, so we don't have to use std again and again. Now we would just write our code inside the main function. Now first of all, we would initialize the array, which is we would let's say as AR, let's say it's as AR, and it would be contains 10 elements. Now we would also be requiring few variables, I to iterate and num to save the desired number. Index we would be using to store the position of the desired element, and we would also have one flag which we would later on know why we would be using it. We would initialize it as 0. So now let's ask the user to enter 10 elements. So we would say enter 10 numbers. Now for I is equal to 0, I less than 10, I plus plus. Let's take the elements from the user. Here we will be taking the 10 elements, and now let's ask the user about what number he or she has to find out. So enter a number to search. Now let's store it inside num. Now what we have done here is that we have taken 10 numbers from the user, and we have also asked the user to specify which number he has to find out. Now we will say for I is equal to 0, I less than 10, I plus plus. We would iterate through the array. We would find if the position of the element of the array at that particular position has our desired number or not. So if it does have, if it's true, then we would store its index value where it is inside the index variable. Now we would also increment the flag so as to tell the flag that the number has been found, and we would later on use it. Now here you could see that we have gone inside the array. We have for now the I value would be 0, so we would see search for the 0th element. If it's equal to a number, then we would store its position, and then we go on doing this from 0 to 10, like first 0th index element, first index number, second index number, and so on. Now we would just we would have add a break statement here. Cool. Now it go out of the both of the loop. Now we would specify if the flag is equal to 0. That means the number has not been found. If the number has been found, the flag increases. It increments. If it doesn't, then it is not found. So we would specifying here for the statement that the element is not found. So we would say here element not found. Okay. And the other else statement would be cout element is at index number, and you would specify it here. So yeah, now if the flag is not equal to 0 means it has found the element. So that's why here we are writing it in the else statement, and we will just end it by cout end and return 0. Yep, this is how it would look like. We have got an extra bracket here. Cool. Now let's just run and see it. Okay, I've missed something here. Okay, I've missed a state semicolon here. Now we would just run and see it. We would just clear and run and see it again. Okay, so I would be adding 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now let's just find a number which is present inside. So I just put 5. So it is at the 4th index. So yeah, now I'll just run it again and check it for the number which is not present inside. So just 1, 2, 3, 4, 5, 6, 7, 8, 9. Now just search for 11. See, now it says element not found. So this was the very basic program of the element. Now here you could see that if we try with a duplicate element, like let's say 1, 2, 2, 2, 3, 4, 4, 5, 6, 7. Now here you could see there are different type of tools. So if I type, it returns the value of the first index which it found. If it has found the element, it would directly go out of the loop and see or display the where it is. So it doesn't go to the other indexes. So we would see in the other program how it goes. So here we would start with our code of duplicate element. So now we have included basic in library of iostream and have specified using namespace std. Now we would write our program inside the main function. So we would write int main, and we would initialize few arrays inside it. Let's say this array is for 100 elements. We would specify some variables which we would be using it afterwards, and we would also specify a second array which we would use to store the indexes of the element found. So yeah, you would just figure it out in a few seconds. So now we would also initialize j as 0 and check, we would use check as 0 as well here. It would act as a flag. Now we would ask the user to enter the element, enter the size of the element of the array. And cn dot, we would take the size inside the tot variable, and then we would just ask the user to enter the two elements. Now for we would iterate, we would take the values of the elements of the array. We would just initialize I as 0, I less than the size of the array, and increment I, and the inside we would store it inside the array I. So yeah, and we would also ask the user which element is to be found. Enter. Okay, I've done here a spelling mistake. Enter the number to be found. We would store it inside the num. So we would compare num with the elements. Now we would just iterate through the array to find out where the element lies. So I is equal to 0, I less than the size of the array, and we increment the ith value. Now we check whether the element at the ith position in the array is equal to the desired number which we require. If it does, then we will store that position inside our other array, which is the temp, and we would store it at the jth index of the temp. We have initialized j as 0 above, as you can see. So the position of the number found would be stored inside the AR temp array, and then we would just go on increasing the, so it iterate through this array as well, and then we would do check chk++ increment check, so that check we have initialized check as 0, so that know that why I have done it, we would later on know it. So here we would just go outside the loops and see if check is greater than 0, which would be true when we found an element. So if it is greater than 0, then cout number found at ut is equal to check. So for r is equal to 0, we'll treat I less than ut. I, we would increment I, and then let's say cout e, we would just cout our other array which contains the positions, so it would be displayed this many times. So we'll say here, that's it. And now this if statement, for that if statement we would also require an else statement. So yeah, if the flag is, if the check is not greater than equal, not greater than 0, so obviously the element is not being found, so we have to declare that number is not found. Now we will end it with a cout nil and return 0. Now let's try and run it. So okay, here we need space. Now let's try and run it. Okay, I guess I have, okay, here I have to write 0. Okay, cool. Now let's just try and run it. Enter the size of the array. We were taking 5. Now we have to enter 5 array elements. So here are 1, 2, 2, 3, 4. So now I will just write 2 as it has been repeated. Now it shows both the indexes. It is found at 1 and 2 both. Now let's just try for uh, uh, element which is not found. Okay, now let's say 1. So element is number is not found. So yeah, this was for the duplicate elements. So each program has different types of ways to or methods to solve the program. So cases are basically different methods which we use to in order to solve the program. So there are three different cases, which is the best case, worst case, and the average case. So the best case is where minimum time required to find an element, and the worst case is maximum time required to find an element. With respect to linear search, we would only be uh, seeing the time required to find an element. So the best case in linear search would be minimum time required to find an element. In the worst case, maximum time, and the average time between worst and the best. So these are the three different types of cases. Now we would just look at in the worst case. So for linear search, the worst case happens when the element to be searched is not present in the array. When x is suppose x, which we have to find out. So when x is not present, the search function compares it with all the elements of array one by one. Therefore the worst case time complexity of linear search would be on. So this is called the big O. This notation is called the big O. Now we would just jump, we would see the next graph. So in this graph, you could see as the size of the array increases, the number of comparisons also increases. We have to compare an element with more number of elements as compared to the others. So here you could see the red line shows the worst case, and the yellow shows the average case, and the blue shows the best case. That's it for today in this video. Thank you for watching.